Okay. This Hess's law starts with a story problem or paragraph before it. Instead of giving you the data, they're explaining what you need to do to get the data. And then from there, we would just do the problem as normal. So it says, combustion reactions involve reacting a substance with oxygen. So they're kind of giving away a little bit what a combustion reaction is. When compounds containing carbon and hydrogen are combusted, carbon dioxide and water are the products. So again, they basically just told you what to write. Using the enthalpies of combustion for C4H4, C4H8, and H2, calculate the change in enthalpy for the reaction. So I need to set up my data. And I know, based on what they're saying, everything is a combustion reaction. So my first reaction has to be the C4H4. And as it said, a combustion reaction is what plus what? Plus O2 will give me CO2 plus H2O. And we know that the enthalpy change for that is a negative 2,341 kilojoules per mole. Do we follow? 2 will be C4H8 we are going to combust it, so it's the same thing. O2 makes CO2 plus H2O, and we know the change in enthalpy is negative 2,755 kilojoules per mole. The last one is the combustion of H2. So it'll be H2 plus O2. Can I make the CO2 in this case? No, because there's no carbon in that case. So my final thing will be H2O as a liquid. So I should change these to be liquid and change these to be gas. Are we good so far? And my change in enthalpy, it told me of that one, is negative 286 kilojoules per mole. So the thing we need to be careful with in a problem like this is they didn't give you the data. We have to pull it out of the information up top. Now, biggest problem we have here is these equations are not balanced. If we look at our data, the energy is kilojoules per mole. So when I go through and balance these, I need to make sure I'm always dealing with 1 mole. So if you've seen these before, sometimes there's a half, like you have a half mole or something on there. That is because it's been simplified down. So the thing we really care about is just 1 mole. So in this case, the thing we really care about is the C4H4, so it has to stay at 1. And then the other one is C4H8, which has to stay at 1. So let's look at 1. To balance it, how many CO2s do I need? 4. How many H2Os do I need? 2. So now that gives me 8 O's and 2 O's, so I'm at 10. So how many O2s do I need? 5. And I still have my 1 C4H4, so we're okay. If I look at 2, how many CO2s do I need? I need 4. How many H2Os do I need? I need 4. So I have 8 and 4, which is 12. Yep, so I need 6 O2 over here. And if I look over here, H2O, or H2 plus O2, what do I need to do? I would have to put a 2 in front of this, and I'd have to put a 2 in front of the H. But obviously, that does not work. So what I need to do is I need a half here. That is because I want that H2 to be 1 mole. So that data it's giving me, because it says it's the combustion for just one H2. So that data to match, I needed that to be half. So if it was balanced, it would be 2, 1, 2. Cut it in half. 1, half, 1. Do we follow? Now, we can solve. So as I said to do with these before, we need to select everything that we need from the equation that we have in the data. So on this one, from equation 1, what is important from equation 1 that I need for my final answer? C4, H4. So this is the important part. From the second equation, what's the super important part? C4H8. And from the third equation, what's the important part? H2. All right, let's set it up. Do I need to change equation 1? Is the C4H4 in the proper place?
Yes.
Yeah. And it's the proper amount, so I don't need to divide it, I don't need to flip it. So I can just write it as is. C4H4 plus 5O2 makes 4CO2 plus 2H2O. And my change in enthalpy is still negative 2,341 kilojoules per mole. For equation 2, is the thing I need, the C4H8, in the right position? No, it is a reactant in the data. It needs to be a product. So on that one, I am going to flip it. It is in the right amount, so I don't need to divide it or multiply it by anything. So in this case, it's going to be 4 CO2 plus 4 H2O is going to make C4 H8 plus 6 O2. And because I flipped it, my change in enthalpy will now be a positive 2,755 kilojoules per mole. Because we've done 2, let's kind of simplify to make our life a little bit easier. What on the left and right of the arrow do I have the same? Yeah, I have O2s on both sides. I have a 6 and a 5. So I can get rid of the 5 one completely, leaving me with how many on the other side? Just 1. I have CO2 on both sides. How many of both? 4. So those are both completely gone. And based on my H2Os, I have 4 and 2. I can completely lose the 2. And this leaves me with 2 H2Os. So when I recombine, get rid of everything that I just canceled, I am C4H4, which is a gas, plus 2 H2O. And I am C4H8 plus O2. To get my change in enthalpy, I just add those two values together. So negative 2,341 plus 2,755. So my change right now is a positive 414 kilojoules per mole. All right, then we have to add step 3. What in step 3 do we need for our final answer? The H2. Do I have it in the right position? Yeah. it's a reactant. It needs to be a reactant, so I don't need to flip. However, do I have the right amount? No. So I need to take that entire reaction, I need to multiply it by 2 because it needs to be 2H2 up top. So when I do that, it will be 2H2 plus, what's 2 times a half? Just 1, so just an OH. Or sorry, just an O2. And then 2H2O. That should be a gas. Okay. Because I multiplied by 2, I need to multiply the enthalpy by 2, but I do not need to flip the sign because we did not flip the equation. So negative 286 times 2. So like you said, negative 572. Let's slide it up just a little bit. Let's cancel out what we need to cancel out. So what do I have on the left and right that can cancel? Well, I have 1O2, 1O2, and I have 2H2O and 2H2O. And that'll give us what we wanted, C4H4 as a gas, plus 2H2 as a gas, makes C4H8 as a gas. It completely matches this right here. When you are given the data, it's a safe assumption to make that they will all cancel. In this case, it's a little bit of an extra step because we have to make that data. We have to make those combustion reactions, properly balance them, and then give us our enthalpy changes at the end. If we do not balance it correctly, we wouldn't have got here. If we not set them up correctly, we would not have got here. So this one's a little bit more difficult on that end than a normal problem would be because we had to set up that data.
How did you get the -5?
I got the negative 572 because equation 3 was a negative 286. I had to multiply equation 3 by 2. So to get my final answer, which is what it wants, we have the right equation, so we know we're going to get the right answer. Our change in enthalpy is just adding up these last two parts. So 414 plus a negative 572 gives me a difference of negative 158 kilojoules per mole released. Is that endothermic or exothermic? It would be being released, yep, exothermic, because it is a negative value, so we know it is going out. So this one, a little bit more complicated than the others that give you those sets of data, because you have to come up with your set of data, but same process. Once we drew those 3 combustion reactions and balanced them correctly, we were able to then set it up. And the key thing with the balancing was that you got to remember the data is kilojoule per mole. So that important piece you want there has to be 1 mole. This number 1 had to be 1 mole of C4H4, 1 mole of C4H8, and 1 mole of H2, because the data up top was just giving you that for 1, 1, and 1. So that would be your answer, negative 158 kilojoules per mole.